In this video, I introduce a new importance sampling from machine learning. Our goal is to compute the integral of a function f times function a. By using Monte Carlo approximation, we convert this integral to an expectation of a function a over the distribution f. If f is a complex distribution, we can introduce a simple distribution e. And then using the Monte Carlo approximation again to convert this integral to expectation of w times a over distribution g. Here, w is equal to f divided by g. If we can get the samples x1 to n from a simple distribution g, we can calculate the normalized expectation. This normalized expectation converges to the true expectation as n tends to infinity. However, if f is a complex distribution, it's very hard to specify a simple distribution g. Annealed importance sampling is used to generate samples x and compute weights w without knowing distribution g. The idea is we start from a prior probability distribution Pn. We generate x. And then we use the state transition probability T to generate a Markov chain. And then use this each x to calculate the f at each point to get the sequential f functions. And then from sequential f, we calculate this w. And we use the final x0 as the independent sample x. So we use this independent sample x and weight w. We can calculate the normalized expectation. To generate x and corresponding weights by using annealed importance sampling, we start from prior Pn and use the state transition probability to produce a sequence of Markov chain points x n-1 to x0. And namely, start from this Pn as prior. We sample x n-1. And then we calculate f n-1 and f n at a sample x n-1. And then we use this state transition probability T to generate x minus 2. And then we calculate f n-2 and n-1 at x n-2, step by step until we reach the x0. And then we use this x0 as an independent sample. Because these samples are independent sample, so we need, for each independent sample, we start from this prior and repeat the same procedure to generate x1, x2, x3. And then we use the sequential f functions to calculate the weight w. From this weight w and independent samples x, we can calculate the normalized expectation of function a. For more details, please check with this reference. Thank you. Bye.